This is section 3.2, linear equations and two variables. Here we're going to talk about how to graph equations and what solutions look like when you have an equation with two variables. The general form is ax plus by equals c. A, b, and c are just numbers in this case. X and y are the variables. This isn't very useful of a formula though because it doesn't tell us anything about the equation. Often we'll want equations in this form, which is called y equals mx plus b, or the slope-intercept form. But either way, it's linear if it just has an x and a y, and both variables are to the first power, right? So there's no x squared or y to the third. There's no square roots. There's no variables in the denominator. And the most important thing to keep in mind here, because we're going to go back and forth between the equation and the graph, is that points on the line, so on the graph, are the same as solutions to the equation. A solution to an equation in two variables is a point. It'll be an x and a y that will make the statement true. So here we have the equation y equals x plus 3, and we have the point 1, 4. And we're trying to figure out, does this point lie on the line of this equation? So the way to figure that out is to take the x-coordinate, which is 1, and the y-coordinate, which is 4, and plug them into your x and y in the equation and see if you get something that's equal. So I've done that here. I plugged in 4 for y and 1 for x, and I get 4 equals 1 plus 3. 1 plus 3 is 4, so I get 4 equals 4. So since it checks out, since I get a true statement, that means that this point lies on this line. Or in other words, if you were to graph this line, it would go through this point. Here is the justification for that. Here's the equation, and here's the line that we just graphed. So this line represents this equation. And here's the point 1, 4, and obviously right here, obviously the line goes through it. So this line is representing an infinite number of points, but every single point on this line has to solve this equation. So obviously like 1, 4 is an example, but so is 2, 5, right? When you plug in 2 for x, 2 plus 3 equals 5. There's the point 2, 5. So this line represents, or any line of an equation, it represents all the solutions to the equation. Our first method for graphing a line will be picking values for either x or y, plugging them into the equation, and solving for the other variable. So here we've picked 3 values for x, and we're going to plug each of those in for x and see what we get for y. I picked these values pretty arbitrarily, but in general I like to pick something negative, I like to pick 0, and I like to pick something positive, just to get a big picture of what's going on the actual line. So we're going to start with negative 2. We're going to plug in negative 2 for x, and then we're going to solve for y. Now y equals 2 times negative 2 will be negative 4, and negative 4 minus 3 will be negative 7. So our first point, we figured out when x is negative 2, y is negative 7. If we go through and plug in 0, this one's pretty easy. Y equals 2 times 0 minus 3. 2 times 0 is just 0, so you get y equals minus 3. So there's our second point, 0, negative 3. And we could probably do this in our head. If you plug in 2 for x, you'll get 2 times 2, which is 4, and 4 minus 3 is 1. So when x is 2, y is 1. Those are our 3 points. Now that we have our 3 points, we can just plot them and basically draw a line through it. So we'll start with negative 2, 7. That means we're going to go negative 2, so 2 to the left, and negative 7 down 7. So our point will be right about here. Then we have 0, negative 3. So that means 0 left or right, so 0 in the x direction, we don't go left or right at all. And negative 3 in the y means we go down 3. Something about there. And then 2, 1, that means we're going to go right 2 and up 1. So our last point, whoops, not great. There we go, right about there. So you can see how these fall in a perfectly straight line, which is the point. And if we try to draw a straight line through them, roughly, let me just, there we go. This is the line that represents the equation y equals 2x minus 3. One more graphing problem. This time I've given you a couple x's and a y, and I want you to solve for the other coordinate for each of these. So basically, if you have an x value, you'll plug it in and solve for y. If you have a y value, you'll plug it in and solve for x. So we're starting off with x is 1, so I'll plug in 1 for x, and we're going to solve this for y. This is pretty simple, because if you want to get y by itself, you just need to subtract 1 from both sides, and you get y equals 4. There's our first point, 1, 4. Now for the second one, they're giving us a y value and asking us to solve for x. That's no problem. We'll just take our equation, and instead of replacing x, we'll replace y with 3. And then we'll solve this equation for x. Subtract 3 from both sides. We get x equals 2. There's our second point, 2 comma 3. And then lastly, a negative 1 for y. We'll have x minus 1, or plus a negative, oops, I said 1, minus 1 equals 5. We'll add the 1 to both sides, and we'll get x equals 6. So there are our 3 points. Now that we have our 3 points, we can plot them and draw our graph. So 1, 4, that means we're going to go right 1, up 4. So right 1, up 4 is about there. Then we have 2, 3, right 2, up 3, about there. And negative 1, 6, that's left 1 and up 6. So about there. And then we'll draw a line through it, and that will be our equation. So it doesn't matter which values you pick, really, as long as they can be graphed on your axis. Like obviously I didn't go off to 10 or something like that. Then you should be able to pick an x value or y value, plug it in, and solve for the remaining point. Plot your points, draw a line through it, and there's your graph.